Welcome back to part 5 of the Bionic Hybrid X210 build instructions. In this video we're going to look at putting the motors on the arms and connecting the ESCs up into the power distribution board. Now you see in the picture I've already soldered my motors to my ESCs, and you need to do the same. Now one of the reasons why I chose the Kylin 250 motors, or the motors that I've done in the other videos which I've chosen for you guys to buy, which are the multi-star motors, is because when you chop the leads off, that you can actually solder them. Some motors come with like enamel around the wires, which needs to be scraped and filed off, which is really annoying and very time consuming, to be fair. So hopefully you won't be presented that problem. Now just to make things simple, we're just going to solder the wires one to one, so left one to left pin, middle one to middle pin, and right one to right pin, and then we'll do the direction later. So before we go any further, we should probably really discuss the direction of the motors. So the top right one needs to spin in an anti-clockwise direction, and the bottom right one needs to spin in the clockwise direction, and the bottom left in a anti-clockwise direction, and the top right in a clockwise direction, like this. So essentially the front and back of the frame are pushing air into the middle of the frame as they spin round. And I realise that my model here is the wrong way around. That's the front, you can see, but it doesn't matter whether it's 180 degrees spun or not. This will be the same. Now, detecting which way the motors spin, well, I always look at it this way. If you loosen the top nut off and then start spinning the motor in the way I just showed you, like this, then what should actually happen is it should tighten that down until it stops. If you've got the wrong motor on the wrong arm, like this, and you loosen that off at the top and then start spinning it in the way for that arm should be, like this, then what will actually happen is the nut will come undone and your actual prop would actually fly off. Not a good thing to happen. Most motors are actually marked though, clockwise and counterclockwise, or CW and CCW. Okay, so now we've got that out of the way, let's just understand that the motors themselves have actual numbers. So the bottom right is number 1, the top right is 2, the bottom left is 3, and the top right is number 4. We don't really need to know this right now, but just notice the ways again with this diagram that the props are spinning, pushing the air into the middle of the frame. So we're now going to go ahead and start fitting one of the motors. Now for this I use some shrink tube, some 10mm shrink tube, and this is really just to protect the ESC. So you want a piece as long as the ESC, and to protect the ESC from rubbing on that carbon fibre. Carbon fibre is actually very conductive, and essentially what you've got there is this ESC will be powered directly from the battery. So if you create a short circuit, you're going to release the magic smoke really pretty quickly, and to some awesome effect, to be fair. But sadly the effect is awesome, but the cost is not. I think you'll probably burn out your motor, your ESC and your power distribution board, and probably not do the battery any good either. So we're just going to fix that shrink tube there just to protect the ESC from the carbon fibre, and just fix it around with a little bit of electrician's tape to put that in place. Just like that, and just push it down at the back so as it's nice and neat and stuck well. Now we're going to go ahead now and start fixing the first motor on there. So it's the top left arm, so that's 1, 2, 3, 4. So I want motor number 4. Okay, I've already pre-marked mine because I know the actual wiring is correct on mine. But as we said before, you may need to rewire yours, so just make sure that when we fix this up, the soldering joint from the motor to the ESC is actually visible and something you could resolder, at least assuming you've got new ESCs, at least 2 of them are going to be incorrect. So one thing to notice here, that when we're using bolts into motors, is we have to make sure that the bolt isn't too long, that it will go through the arm, through the bottom of the motor and touch the windings. Seriously, if your bolts are too long and they actually touch those windings, you will definitely release the magic smoke out of that ESC and that motor, to be fair. So just ensure that they're just the right size. So probably about 3mm normally above, or 3mm longer than the thickness of the arms would be about right. So you're really looking at about 4, 5, 6, you're really looking at about 7mm. So what I do here is I put all my 4 bolts in reasonably tight, but not too tight. And the reason for that is that once they're actually in play, I like to use some Loctite. So just make sure they're tight, just so that it fixes the motor into the correct position. And then we use some red Loctite. Okay, so some people would use blue here, but I prefer red. There's a lot of vibration, especially on these small motors. So now I take each bolt out, apply a little bit of Loctite. Oops. A little bit of Loctite on each one. Run it through my fingers, twisting action. Just clean my hand on a piece of tissue and then in there. Now this time I tighten it down now to its full tightness, how I'm going to leave it. And do the next one. So I'll just fast forward a little bit now, no point in you watching this. Don't forget that once you've finished with the Loctite, put the lid back on, otherwise it'll dry out. And now what we need to do is take some more electrician's tape and actually fix that ESC onto that arm. Now again, remembering that although you don't, I know my wires are soldered correctly for each motor. What you need to do here is just leave the connection wires from the ESC to the motor visible, so you can unsolder them and move 2 wires around if you need to alter the direction of the motor. So again, it's pretty obvious really what I'm doing here, so I'll just fast forward. Okay, so this last piece of tape is pretty, so you're not going completely horizontal to the arm this time. You have to go horizontal to the actual frame itself to wrap, to get as much tape around those wires as possible to try and stop the water going in. That's what we're doing here, by the way. We're trying to stop the water getting to the ESC. ESCs really don't like water, and we can't use the Corrosion X because they really don't like Corrosion X either. So we're just trying to seal that the best we can to stop any small bits of water. I mean, obviously, if it fell in in the lake, then it's going to get in there, and that's going to severely ruin quite a lot of components. To be fair, not only the ESCs but also the camera and probably the video transmitter as well. But what we need to do is thinking about if it's I don't know, falls in some long grass that's a little bit wet because it's been raining. You're trying to stop that kind of water getting into that ESC. Okay, so after doing some double taping just to make sure it's nice and solid and secure, remembering that you're leaving your motor connections visible so you can actually resolder if necessary, then you should end up something looking like this. So once you've got all 4 ESCs and motors attached to the props, it'll be time to solder on to the power distribution board. Now as you can see, I've already cut my leads to just the right length, and I'm going to use a very hot iron. You can need a really good hot iron here. I've turned this up to full, which is 840 C, or well, almost 900 Fahrenheit. So we'll just put a bit of molten solder on the end of the iron there, so we can melt the tabs. Now what I like to do, I always just like to heat up where I'm going to solder to, and re-tin the end of the wire just so everything's a little bit warm, and use just a pair of little pincers and hold it on. Make sure it's nice and melted, not only the end of the wire but also the tablet melting too, and then it should be quite a solid connection. We'll do the same again for the negative wire. The pincers bring it out, tin the wire, nice and warm, holding on, making sure that the end of the wire melts and the tab as good as it can before you let go with the iron. Okay, a little bit of blurred view there, but as you can see, the red's to the positive and the black's to the negative. So we just need to now solder on the rest of the wires, and I'll fast forward over this bit. It's the same process for all the wires. So once we've done that and made sure some of the wires are out of the way, then I don't quite like the look of that solder joint there. It's got a bit thing, but I am reusing this this power distribution board, and there was quite a bit of solder on. Really could do with a really hot iron, but it's going to make a good enough contact. It just looks just doesn't look so good. So we're just going to tie these wires up so they loop round and go through the area that's purposely made for these ESC wires to go. You may also notice that I've lifted the power distribution board up and threaded through the white and black wires underneath the power distribution board, so between the power distribution board and the flight controller mount. So the next step is to actually just test to see which way the motors spin, and before I do that and connect a LiPo battery for this model, I'm just going to double check to make sure I haven't got a short circuit. So if I can hold those in place, to show you there, you can probably just see that it's about 82 kilo ohms, and yours could be anything really. As long as it's kilo ohms, then that should be fine. So let's go ahead and actually plug in the LiPo battery. Now, of course, you can't hear that, but that's you know, made them motors just tweak a little bit. Yours may or may not. It depends on the ESCs, to be fair. So I shouldn't be worried about that. So I just need to plug this now into just a servo tester really. So let's try motor 1, which of course is the bottom right motor. I'm going to plug that into the servo tester. Now what we are going to need is a battery for that servo tester. So let's plug that one in first, like that, just to provide power. My number 1. Need again. Oh yeah, let's put it onto digital, and LN mode and normal will be fine. Like the pulses down to 0. Well, this actually be 1000 microseconds, and drop that in the actually, for some reason, this servo wants to do its full scale, so it works out what you can just see the motor there pulsing. So it basically wanted to see 1000, 2000 microseconds what that looked like, and there you go, the motor's spinning. So I can just turn that up to, I don't know, 1100 microseconds so it doesn't spin too fast, and then you feel the rotation of the motor. Obviously you're doing this without props on, probably very dangerous for you to do it with props on, but that's actually spinning the correct way, so it's spinning in a clockwise direction. So let's try motor number 2. Whack it down to 1000, and then back up slightly. It's starting to spin. You can't quite see from my hand, but it is starting to spin, and I can feel that now it's going round in an anti-clockwise direction, which is exactly how it should be for that particular motor. Now, of course, if yours aren't, what you'd do is you'd actually unsolder 2 of those wires from that motor to AC and just swap them over. You can probably see, actually just make out that this motor I'm about to test now actually has got the crossovered wires. So the middle one goes to the right on the ESC, and the right one goes to the middle of the ESC. And again, we're just going to go from 1000 up to about 1050 by the look of that was, and it's spinning in an anti-clockwise direction, so that one's fine too. And the lucky last motor, I mean, like I say, I'm just showing you this as a demonstration because I know these motors are okay because I've already tested them. This is really just giving you an indication of how I would test them. Now, you can do this in software, so if you don't want to resolder your wires, we will be doing this later in the BL Heli suite, and by using software you can choose the direction of the motor. The reason why I prefer to do it this way is that I like all my ESCs to be programmed with the same settings, because then you can't forget. But it's entirely preferential, really. If you're happy with software and feel comfortable with software, then you probably want to do it in software. And if you prefer to do it in hardware, then it's easier to do it on here. So just to describe that again, if this was spinning the wrong way, you know, and let's say that was spinning clockwise instead of anti-clockwise, then what I would need to do is I'd need to swap two of these wires around on this motor here. Now, as you can see, I've already swapped them over, so the middle motor wire goes off to the top one there, and the other one goes across, whereas that one goes straight across. Like you see, so that one's the middle wires to the middle, left to the left, right to the right, whereas that one is the top one is to the middle one's to the top one, and the bottom one's direct to the bottom one, and that's why those two motors spin in different directions. Hopefully that's clear. So if you've done all that, you should end up with a model that looks a little bit like this, with all the tape on, protecting the ESCs, the motor spinning in the right directions, and everything ready to start the next task.